Okay, good morning again. Good morning to everybody, and thank you for this opportunity to present this device. But let me to start with these slides that introduce the actual participant in this project. One is Davide Dardanello, a physical therapist, and that was the person that had the first idea for this project and push all of us in this direction. And after me, there is Deborah, of course, that we consider a sort of end user of this device, because with her we try to assess the characteristics of the device. And of course, OTB Elettronica, also because if OTB Elettronica was not here, I have no reason to talk now. Okay, a very short summary about the reason for which could be interesting and useful to have a device to assess force, pain of muscles. The reason is that musculoskeletal disorders with the mental and behavioral disorders are the most important disorder that are in general in the world. And yeah, thank you. And among musculoskeletal disorder, low back pain, neck pain, and other disorder are fill the first position in this ranking. So for this reason, we start we consider also the fact that a huge number of physiotherapists are in the world. Only in Europe, Eurostat counts more than 500,000 physiotherapists. So we have a huge amount of people that could use this device that I'm introducing you now. Okay. This we call this device NOD, and we start from the first feature, that is a force biofeedback. Thank you. Okay, we start from the craniocervical flexion test, a test that maybe you know, that for sure all physiotherapists know, that is used for the assessment of the quality of the neck flexor. I can show you here, the main part of this test. The first one, the first one is that you record the EMG signal from superficial muscles. The second one is this pressure device, because during the notch of this movement, the head moving in such a way, you produce a pressure over this bag, and this pressure is produce a biofeedback that the subject can see. Okay. So the neck pain is due to a lesion or something similar to the deep muscle, but they measure superficial muscle to see if they are used instead of deep muscle. Yeah. So this is a typical pattern of an exercise done with the neck muscle for an asymptomatic subject. You can see here that if you increase the pressure, if you increase the force you are producing during the notch, the superficial muscle should not work. And they work if you increase so much the effort, so for co-contraction or something similar. This is a pattern for an asymptomatic subject. This is clearly a situation very different for a symptomatic subject with, for instance, neck pain or whiplash. You can see here that the subject was not able to maintain the force in a regular way, so deficit in motor control, and she used superficial muscle instead of deep muscles. Okay, so this is the device that is used throughout the world. It's a pressure bag, and the limitation that we try to overcome are the fact that the measure there is no possibility to record them. The second one is that there is no possibility to transmit such measures, and the one also most important limitation is that the actual scale is that one in the upper left side where you see the three color bar. So a very narrow scale with a very, very low resolution. This is what we propose and we built with, within this project. Is a device that is here, in which you can produce a force exactly in the same way of the pressure bag, but the biofeedback is there, and you can see that with a very higher resolution. You can transmit that via Bluetooth, and you can save all the data. Yeah. Okay, so when you have this kind of device, you think that you can do something further, and so we try to increase the possibility of use of this device, adding an algometer and a dynamometer. An algometer, you know that we have on the market a huge amount of these devices to measure pain, and we add a spare part, obtaining an algometer in the same way. And some dedicated apps are just available on the website, and you can obtain them on your smartphone, and for each of these tools. And the final one is the dynamometer. In the same way, you can measure the force for each of the limb, and the full scale actual is 50 kilograms. Okay? So let me to go ahead with a very short movie. I skip the sound because it's not very important. Okay, the dedicated app allows you to use it as an algometer to track, as all the algometer do, the pressure in time, or to provide biofeedback on both tablet or smartphone. Okay, in the same way, to allow to record in a more quantitative way the force produced by your patient subject, to hold it, to compare, and track in time if your rehabilitation program introduced some change. Okay, so what we have to do now is to assess in a very quantitative way the reliability and repeatability of such a device. And to do that, a cohort study will start in Birmingham as soon as possible, just to obtain information about the feature of this device and to compare it with the device actually at the moment used. Okay, that's it. Thank you.